What is up? You guessed it. It's Mr. Osley here. Today is the last time that we will be doing this. It's kind of sad, but it also makes me kind of glad. Hey, if you're thinking about me this summer, I'd appreciate it if you prayed for me. I'm starting my master's degree, I think in like June. I think June is when it starts. So I'm getting a master's degree from Bob Jones, all online, so I won't actually have to go anywhere. So if you guys would pray for me, I would appreciate it. I'm going to be doing a lot of work, writing a lot of papers. The grind never stops, right? So, hey, say a prayer for me. Yeah, I'd greatly appreciate it. All right, so let's jump in here to number 5. Hey, while I'm thinking about it, I'm wondering how many of you guys have a summer job, or how many of you guys will have a summer job. Summer jobs are a great tool that I used, at least when I was your guys' age, to put some cash in my pocket and start saving up. Let's see, when I was in high school, I had kind of 2 summer jobs. I worked maintenance a little bit at my church. That was one of them. I didn't do that. I think I did that. I don't know. I was like a sophomore and junior. But mainly from like my sophomore through senior year, my main summer job was just doing landscaping work for a bunch of people. So cutting grass, putting out mulch. Honestly, mulch is like the best money. That's the best money maker. But it's probably the hardest work. I remember, you guys know what my truck looks like. Whenever I would do a mulch job, the people would pay me the money to get the mulch, so I would drive to the landfill, which wasn't that far from my house, and I would just say, hey, I need a truck bed of mulch, which honestly, it wasn't like super expensive. I can't even remember how much it actually cost, because they make the mulch there at the landfill, but it was like maybe like 20 bucks a truck bed, between 20 and 40 bucks a truck bed, I can't remember. Well, I would pay for it, they would pay me back later, but they would load me up. I'm talking like hundreds of pounds of mulch. It was unbelievable. Like, my truck looked like a squatted truck driving down the road. You guys know what I'm talking about. That was just because I had so much mulch in the back. Anyways, it would usually take me, I don't know. It would usually take me like a whole day to put it out. Because I would work by myself, right? Because I'm not paying somebody to work for me. I'm keeping all the money. So I would go put it out, and it was like back-breaking work, right? So I'd have my wheelbarrow, my pitchfork. That's the best tool, a pitchfork. It's way better than a shovel for spreading mulch. I would have my pitchfork and my wheelbarrow. Oh, killed me. Literally killed me. But that was always the best money. Usually, like, personally, I usually charge like 20 bucks an hour for manual labor. That's a safe going rate, especially when you're working for yourself. So I charged like 20 bucks an hour, which is good. That's a good price, compared to some people. So they'd pay me, and usually it would take me like, I don't know, like 8, 9, sometimes 10 hours. So you're looking at 200 bucks, plus they would reimburse me for buying the mulch, plus I would charge them a little bit for the use of my vehicle, just because, it's not free. You know what I'm saying? I had to use my gas and squat my truck and whatnot. But anyhow, good money. I don't know why I started talking about that. Beats me. Anyways, if you guys have a summer job, work hard, earn some money, don't spend it all, save some, and you'll be glad you did, for sure. Okay, number 5. In exercises 5 to 12, sketch the graph of each function and state the domain and range. Okay, so basically we're just sketching a graph, and then we're trying to state the domain and range. Okay, so number 5, f of x equals the square root of x minus 3. If we had more time in this class, our next section, we were going to be talking about transformations. Basically, a transformation and a translation of a graph is just taking a graph and shifting it. Okay, shifting it up, shifting it down, left and right. There are keys and tools you can use to figure out like exactly what this looks like. The reason we studied the toolkit functions, guys, is because this is just a variation of the toolkit function. Okay, the toolkit function for the graph of the square root of x, I know exactly what it looks like, right? Because it's one of those common functions. The graph of the square root of x looks like this right here. Okay, so if I take this translation here and I plug it into my calculator, let's graph it. Okay, so y equals the square root of x minus 3. So this is our actual graph that we're trying to do. You'll see that the graph basically looks the same, except it just shifted it to the right. And that's a key that you can use. Inside the square root sign here, this is weird. This is not what we're used to. A minus sign will shift something to the right. A plus sign will shift it to the left. Okay, so if you remember that, hey, it makes it really easy to sketch the graph. Okay, so I would take my normal graph, 1, 2, 3, shift it 3 to the right, and then sketch it. Okay, so it makes it really, really, really easy. Now, domain, the domain is the x values, right? You can see that it exists for everything after 3 in the positive direction. So if I wanted to write the domain, I'd say domain, let's see here, we'd say negative 3 is less than or equal to x, which is less than infinity. Now, if I wanted to write the range, it never drops below 0, and technically it keeps going here in the upwards direction. So we would go 0 is less than or equal to y, which is less than infinity. So just this expression here tells me every x and every y that will appear in this problem. Not too difficult. Okay, so number 6, 8, square root of 8 minus x. Now this one's a little bit different than what we saw before. Okay, so this negative here in front of the x means something's going to happen. And then this one here also means something. If we wanted, we could actually write this a different way. It might help us see it better. We could write this as the square root of negative x plus 8. This and these two things are the exact same. Okay, so this brings us back to the original how we see it. And this negative is going to do something. Okay. This 8, remember a positive number shifts it to the left. Okay, now we need to find out what this negative in front of the x does. So first of all, I'm going to change our window settings. We're going to say negative 10 to 10 again. Okay, so now, let me change the y as well. Okay, so if we come here to graph it, we're graphing, once again, square root of 8 minus x. We'll just put the original in. It's the same thing. Okay, so the square root of 8 minus x, close my parentheses, hit graph. Okay, so some weird things happen here. Let's graph the other one to make sure that the two are the same. Okay, so let's graph negative x plus 8. Square root, let's see here, square root, where's that button? There you go, square root of negative x plus 8. And yes, they are the same exact graph. Okay, so basically what has happened here, this negative sign has thrown everything off. So if we graph this, if we sketch a graph, having this negative here affects this one. So it shifted us 8 this way, and it made our graph flip directions. Right, so instead of going in this direction, it made us flip and go that direction. Okay, so let's write our domain and our range for the problem. Okay, the domain, all of the x values, we have everything here from positive 8 and then into the negative direction. So we will say for the domain, we'll say, we don't need that, sorry, negative infinity is less than x, which is less than or equal to 8. Okay, for the range, remember it goes from 0 and then it grows. Okay, so everything, we'll say 0 is less than or equal to y, which is less than infinity. Basically, guys, anywhere that it actually touches, we're going to use this less than or equal to, and then the only time we're really using less than or greater than is for infinity. Okay, alright, and that's our answer. Sweet. Okay, let's talk about this one. 1 over x squared. This was, I believe, one of our toolkit functions. Let's graph it and let's see what happens. Okay, so 1 divided by x squared, we'll graph it, and there you go. Okay, so this 1 divided, this actually might not have been one of our toolkit functions. Alright, so it looks like this here. It's a very unique graph. Okay, so basically the graph goes everywhere except for when x is equal to 0. You can't even see that, I'm sorry. It goes everywhere except for when x is equal to 0. At that point it stops existing. Okay, It also, for the range, it doesn't drop below 0, right? It actually never touches 0 either. Okay, so let's write our domain and range. Excuse me. Something in the air. Okay, domain and range. Okay, so domain is the x values. It goes everything from negative infinity until we get to 0. Okay, then it goes everything from 0 to positive infinity, just not 0. Hey, here's an easy way we can write this. We can say domain x equals all real numbers. We'll put a semicolon, but we'll say x cannot equal 0. Okay, so x is all real numbers, so negative infinity to positive infinity except for 0. That's all that means. Okay, so some fancy symbols, but not too complicated. Alright, range. Once again, that's my outputs. So my y's, we never touch 0 or go lower. We have everything up here. So we can say y is greater than 0. That's an easy one. Y is greater than 0. Okay, it never equals 0. It never goes below 0. It's just greater than 0. And there's our domain and range. Alright. Hey, let's see what's on the back. Let's see what's on the back real fast. I want us to do this one. Okay, that other one's kind of complicated for the time we have remaining. So let's do this one here. F of x equals x squared minus 4. Focus our camera. Apologize about that. Okay, f of x equals x squared minus 4. So here we have our graph. First of all, what does the original graph for x squared look like? Let me see, make sure you guys can see that. Okay, so the original graph for x squared looks like this, right? A parabola. Okay, so all we have is this minus 4 thrown in right here. Okay, so we need to think, what does this do? Well, this is what is called a vertical translation. Okay, the vertical translation, all it's going to do is going to translate it up and down. Okay, a minus sign is going to translate us down. So 1, 2, 3, 4. We'll put our vertex and then draw our normal parabola. Let's check our answer and see where we write. Okay, so we're going to put x squared minus 4. We're going to graph it, and voila, we are correct. Okay, so it just is a vertical horizontal translation. That's all it is. Okay, let's talk about the domain and range. Domain is going to be easy for this one. Is there ever a point where x doesn't exist? The answer is no. So we're going to say all real numbers. There you go. Okay, range, the y values. We have everything from negative 4 on up. Okay, so we'll say negative 4 is less than or equal to y, which is less than infinity. Okay, so some bookkeeping here. That's all that is. Let's see. Let's do one more. Let's do this number 11 here. F of x equals x cubed plus 2. Alright, this is just like the last problem. It's one of those vertical horizontal translations. Okay, the original graph, let's see here, the original graph for x cubed, this was one of our toolkit functions. The original graph for x cubed looks like this. Okay, so it's this same graph except we've shifted up 2. Okay, so we'll say 1, 2. Alright, and now we just draw our normal graph. Hey, this one's easy for domain and range. They're both all real numbers. Hey, tell you what, we're going to call it quits there. Hey, I enjoyed teaching you this year. I really did. You guys taught me a lot. I look forward to seeing you next year. I don't know what happens. Hopefully, I'll be able to teach us something. Who knows? I guess we'll cross that bridge when we come to it. Alright? Other than that, you guys have a great summer. Make sure you turn this in at the final turn-in day. I look forward to seeing you soon. I'm praying for you. If you have any questions or if I can help you in any way, let me know. For the last time, adios.